And I'm going to introduce you to Mark Kennedy and Igor Mitnick, who are going to be presenting the IEEE Software Taggant System.
Thank you.
Hi.
Okay, as it was mentioned, we're from the IEEE, and the way this comes about is we're representing the IEEE. We actually work for different companies. I work for Symantec, and I'm the chairman of the malware working group in the IEEE Industry Connection Security Group. And Dr. Igor Mitnick is the vice chair, and he works for McAfee Intel. The membership of our working group consists of a lot of antivirus vendors, and we also have a number of Packer vendors who have joined as subject experts to help us with this current project that we're working on, that we're unveiling to you today. So what we're going to talk about today is the problem that we're trying to solve, the solution that we've come up with, which is the software taggant system, who the players are, what the benefits to all the people involved with the project are, the difference between taggants and authenticode. We'll get into a little bit of how the system is going to work, what the life cycle looks like, and then the current status of our project. So the problem we're trying to solve is malicious software users utilize software packers to, well, a software packer will take code and either compress it or obfuscate it. The packing changes the executable by either compression, anti-debugging techniques in it, trying to protect intellectual property. Sometimes they'll virtualize the code into P code and execute it using an interpreter, or they'll use any combination of the above methods. And each of the packers has a different number of options that you can supply to it on the command line when you're creating your packer. And by varying these options, you can take a single executable and make a near limitless number of variants that function identically but are different binaries. So this serves as a very cheap form of server-side polymorphism for malware authors. Igor? I forgot to ask a question.
Hi, everyone. I'm Igor. That was Mark. So the question you are probably dying to learn about is what the hell these guys are talking about. What is a taggant? Let's run a poll. Whoever knows what taggant means or used for, could you please raise the hand? Don't read the screen yet. Okay. Taggants are used for physical security and in tracking explosives after they obviously caused some issues to find where the source of that particular problematic explosive was. So by examining the chemical which was added at the manufacturing time, one can determine whether it was plant A or plant B or plant C and react accordingly. We use this term to disassociate what we do within IEEE with using PKI and digital signatures to mark executables, because traditional digital signing, watermarking, authentic code, all these terms are a bit overloaded, carry some historical baggage, and what we were doing is slightly different. And the taggant, software taggant, seems to fit the bill for what we were looking for very, very well. So what is a software taggant? It's a solution to the problem Mark described, cheap form of software polymorphism created with packers. And software taggant allows marking executable by putting a digital signature inside it, injecting it after the packing. And this digital signature would allow us to pinpoint the origin of that particular executable. So if there are three users like Alice, Bob, and Carol, we would be able to say that this program was created by Alice and not Bob. That's very useful because that allows us to blacklist particular source of executables if this source appears to be a bad one. Also, it serves a purpose of verifying the integrity of the file. The Taggant system will utilize PKI, will explain how, and what the system consists of is mainly a C library. C library is used at the stage of packing an executable to place a taggant into it, and at the time of examining the executable on the user system. That would be done by security software. The whole approach allows, by tracking the source, to de-anonymize the sources of programs, packed programs, and malware. Let's touch on what players are involved in this process of creating executables and using them. It's not quite completely trivial, because there are two types of vendors and two types of users. First is antivirus companies. These guys are looking at packed executables and get really suspicious of them, because quite a lot of malware is coming in packed form, and legitimate software is not frequently packed. And there are also packer vendors, vendors who produce packing software and sell it. That's companies like Armadillo, Femida, VMProtect, and similar. These guys sell their software to their users, and their users are software houses, game developers, whoever wants to protect their intellectual property, and sometimes bad guys too. They can obtain legitimately software licenses from packer vendors and abuse them and pack malware with them. That's why we want to know that this license is known to be good, and this license is poisoned. Introducing the Taggant system would bring benefits for everyone. It will give more proactive protection for antivirus companies. It will reduce the number of false positives. Instead of blacklisting entire production of a packer, we would be able to say it's this specific source, which is poisoned. It will less tax resources of security companies on investigating these problems. Software packer vendors will actually be part of the solution. There would be less false positives on what is produced with their software. They will have competitive benefits as well, because that would occur only to production of software packers involved in this project. If they don't get involved or do not wish to get involved, they wouldn't reap the benefits of the system. And packer users, like software developers, gaming companies, they'll see less false positives and better performance, because the antivirus companies would be less suspicious, wouldn't try to emulate, get into the file to actually analyze what's under the packer. We are hoping that in time, probably 2 or 3 years, we might be able to remove the source of packed malware as the major malware source. And currently, it's contributing more than 50% of new malware. Now, let me run the poll before I show you the next slide. Do you know what authenticode is? Could you raise a hand if you know what is authenticode? Yeah, there is some knowledge. Authenticode is digital signatures for Windows programs. And Mark will switch over from me.
So a Taggant, it's similar to a digital signature, but it varies in a couple of key ways. First, the packer companies know when they write their packer what is the important part of the code for them to protect, for them to be able to verify that no one has been manipulating in a meaningful way their code in such a way that you can take an executable, modify it, and have it still function, but yet function in a different way than when it was packed. So they will be able to hash just those important areas of the code, and that we call the performant hash. Now, it may turn out that they make a mistake when they do that and find out that they didn't really cover enough of the file. So we have a fallback to a default hash, and there's actually 2 default hashes. One which covers the entire executable from the MZ header all the way to the last byte of the executable, and another one which then also continues that hash on and covers any appended data that the packer puts on. Because some packers will work by putting a stub and then putting important data on at the end of that executable. So we'll cover that one as well. Creating and using files with taggants is free. Once you've bought the packer license and you've activated your license, every time you pack a program, the taggant is automatically applied to it. You don't have to do any extra steps. There's nothing else for you to buy. The PKI infrastructure that's necessary to drive all this will be supported by the AV companies. We're paying for it. We're making it, providing it free of charge to the packer companies and to their end users. And the taggants are compatible with Authenticode. You can take a file that has a taggant and apply a digital signature to it, and the taggant will still be valid, and the digital signature will still be valid. Now, digital signatures, generally in security software, they come with an assumption, if it's class 3 digital signature, with an assumption of goodness. Like you get not only authentication, but you also get sort of reputation as a result of that. That can be obtained over time using the taggant system, because we'll know every piece of software that your license key has ever created. And so by the time we've seen you create 100, 200, 300 programs and they've all been good, then we'll learn that your software is generally good, and you'll start benefiting from the trust of that, where Authenticode allows you to kind of jump that. Okay, let's talk a little bit about how the system works. It's a 3-level PKI system. IEEE is at the root of the trust, and we authorize packer vendors. And when we do that, we generate a unique identifier for them and give them access to the PKI system that allows them to create licenses for their users under this system. They manage the certificates for the packer users. They issue them. They can handle revocation, as can IEEE. One of the keys of the system, though, is the packer companies are never in possession of any of the keys. They're not even in possession of their own keys. That all happens within the PKI, and they're provided to the end user later. Once a user activates, they obtain their license key. When they pack software, that license is embedded with the taggant and used to sign it. And then the AV companies can then validate that the file's not been modified, identify which license was used to generate it, and make its determination as to whether or not that was a blacklisted or a good-to-go license key. Back to Igor.
Okay, let me run you through the entire life cycle of how the system would work. Let's start with the source of the problem. Well, to put it harsh on the packer vendors, because we are trying to solve the problem of packed malware. So the first step for a packer vendor is to approach IEEE and ask for a license for a vendor. Then, after appropriate checks are made, and we establish that it's not basically a malware development outfit, we issue a vendor login, a URL for that specific vendor to always come to and manage his users. Next steps may occur multiple times depending on how many licenses are sold by the packer vendors. Vendor is asking this IEEE URL for a user login. It's one-time generated URL, which is then embedded into the license, which is carried by the packer setup. That makes each packer setup unique, and it will have that URL to activate the Taggant system on installation. That unique installation is shipped to the packer user, like gaming house or other software development house. What they do next? They install the software. The setup goes to that unique URL and generates a key pair unique for that installation. That would differentiate from that moment Alice's, Bob's, and Carol's. Setup gets the certificate back, and when this packer, from that moment in time, obfuscates a file, what will happen? The host file is compressed, or obfuscated. Then a taggant is created which describes the content of that tagged file in a secure way. It generates 3 types of hashes: performant one over just the vital areas of the file, default for the entire PE image, and complete file from top to the end, including the overlay. And that taggant is timestamped. That would allow us to blacklist, for example, Alice starting at that moment in time. But we know that Bob always was good, so we don't apply this time check to a particular source of packed files and files with taggants. Then the certificate for this particular install is included in the taggant, and taggant is written into the packed file. And that packed file can be distributed. It can be a game, or it can be some software where intellectual property is protected. That file reaches the very end user who runs that file. Could be a gamer, could be a other type of program, and it could be malware if at some point in the first 3 steps that process got compromised. But that's okay. As soon as it's compromised, we would know that that particular source is compromised, and as long as we've determined that the file came from that source, we would be able to blacklist this user and everything which is created at that place from that moment in time. So then when the file is run, antivirus software inspects the file. It can reject it. It can determine what the moment of intrusion was, and it will block it if it's bad. Now, what is the status of this project? The group that we worked on with all the antivirus companies produced all the documentation, and today there was a press release from IEEE and about the issuance of a request for proposals. Basically, this request of proposals describes what has to be done, what software has to be written by a third party, because AV companies are hugely competitive. They would prefer a third party to implement that library. And the deadline for this request for proposals is 7th of September. And if you are skilled in crypto, please download that request for papers, have a look, and consider participating. Implementation, and it doesn't seem like it should be a very difficult thing to do. It's supposed to be ready by November 2011. And if you want more details, you can Google for IEEE and Taggant, or there is a link at the end of this slide. And now we'll be ready to answer your questions.
We have 2 minutes for questions.
Was implementation in November?
We're farming out the development of the library to a third-party company, and we're hoping that they will have that finished by November, and that would be, at that time, we'll be ready to start including it in software packers and in security software.
Do you have the packers ready to actually start rolling out in 2011 or 2012?
We've contacted over a dozen software packers, and they're very anxious. Many of their first contact was, when can we have this system? We want it right now. So they're really on board with doing this. We think once they have the library, it should not take them too long to integrate it into their system. So I would guess you would see the first packers rolling out early 2012 that would be Taggant enabled. Also, as a part of the project, we're going to take an open source packer and make it Taggant aware. So that'll be a reference one for people, and IEEE will make that packer available to end users. Yes, sir.
We've seen root certs being taken by malicious third parties recently. What steps are you taking to make sure that this can't be compromised at source?
Okay, the root certificates are all maintained within the certificate authority. They never leave that secure facility. What ends up out in the wild are the individual license keys, and those could be picked off by malware. But the effect of losing your license key is that the person who failed to protect it has their software now sort of flagged as bad. So the person who has the responsibility of protecting the key also bears the consequence of the key being compromised. Beyond that, we're relying on the certificate authority to protect all the other keys. That's why we didn't want the packer vendors to be in the possession of the keys, because that way they would have to be protecting them for all of their users. and then that's not their business. So we prefer to put that in the hands of people who that's their job. But if the keys get, if that CA loses its keys, yeah, we got troubles.
Yeah.
But that's the same if Microsoft's key gets compromised, we've got troubles.
Not disputing that, not trying to be awkward, but it is something that obviously that is your primary proof. So I'm assuming that the IEEE will be sort of embedding it in concrete, locking it away.
Yeah, that's why we're putting it, yeah, it's a way where actually no one really ever has possession of it, just automated systems which access it.
And there are intermediate keys. The actual root generates an intermediate pair, which is then used, which somewhat reduces the chance of compromising the root. Anyway, it was designed with consultancy from Mark's friends at VeriSign, who now work at Semantic, and the entire system is, in this regard, audited.